Hello, everyone. I hope you guys are all okay and having a great day. Today we have a really exciting workshop by Ramesh from Refuel about the new age of data transformation.
Well, good morning, everyone. Well, it's morning for me, 8 a.m. in San Francisco, bright and early. Um, Excited to be chatting with all of you today. My name is Kamesh. I lead growth at a company called Refuel, and I want to spend the next 20 minutes or so talking about what we're building at Refuel, but more importantly, how the world of data science has changed and evolved in the era of Gen AI and how these unsexy data tasks and data problems are being approached from a different lens. And so, how I was thinking we can approach this conversation is share a little bit about who we are, what we're building, what data science used to look like, what data science will look like, what you need to take away, and then I can do a brief overview of the product and answer any questions that folks from the audience may have. Full transparency, I'm not a software engineer, I'm not a data scientist, but I work with a lot of incredibly smart ones. And so, some of the most technical, juicy questions you may have, I may or may not have answers to, but I'll give my best shot to answer them anyway. A little bit about me, as I mentioned, I lead growth at Refuel, and essentially what we're building is an all-in-one platform for data transformation. So unsexy, or let me clarify, AI powered data transformation. So unsexy data tasks in the realm of classification, extraction, enrichment, named entity recognition, NER. These are the sorts of problems we care about, and we predominantly solve them for e-commerce, retail, financial services, enterprise tech such as HR tech, sales tech, you name it. These are the sorts of problems that we care about solving and for these sorts of customers. And in the past 2 years since we've been around, we've been able to deploy hundreds of custom LLMs to help these customers solve some of these unsexy data tasks. Two things we're building. One is a cloud interface that allows users to stitch together these data transformation pipelines. So let's say you needed to extract information from a PDF and then look something up on the internet and then ultimately classify it in a taxonomy of 1,000 different possible categories. We make it very easy and very intuitive to stitch together these workflows. So whether or not you have a machine learning or a data science background, you still have ML and data science capabilities. And in the back end, you have an LLM that's powering all of this. So we've also built a set and series of purpose-built LLMs that really excel at these data transformation tasks. I mentioned classification, enrichment, extraction, NER. These are the sorts of problems we care about, and these are the sorts of problems that Refuel LLM solves. And Refuel LLM is currently available in a variety of sizes, all with different costs and latencies. Cool. So let's talk a little bit about what data science used to look like. So when you think about the conventional process of training a model, usually it was multi-step, right? You would typically ingest some data, validate it, pre-process it, train and tune it, and when you take a look at the outputs, typically analyze, validate, deploy, and give the model feedback iteratively to get to that level of precision and recall and accuracy that you're ultimately looking for. And this wasn't an easy process. It took a non-trivial amount of time, and more importantly, it wasn't very nimble, right? Making adjustments, making iterations, it wasn't straightforward. It took a lot of energy, it took a lot of effort, and getting to that desired accuracy, as mentioned, was a pretty lengthy and significant ordeal. And specifically, what made this process hard was a couple of things. Number one, even the simplest models needed tons of label data to train. Second, you had to trade off between different models, right? Some excelled in some capacities, some had their downsides. So you were essentially picking and choosing depending on which model you were using for your data science experimentation. And third, the process of evals and production monitoring that wasn't intuitive, it wasn't straightforward, it wasn't simple. again, it was a non-trivial ordeal. And so I want to kind of visit this in the lens of a specific case study. And Primer was a company that our founder worked at. And he had an instance where he had to take data from news articles, social media, all this different aggregated text and extract companies, right? Identify what pieces of the text represented organizations and extract them. And ideally, they were shooting for about 90% precision and 90% recall, and essentially had to go through, identifying maybe about 2,000 different organizations. And to do this, they had to produce 10,000 labels, and significant or a majority of them, if not all of them, were hand labeled labels. Which they ultimately ended up building a BERT model as well as a series of custom rules and heuristics to be able to do this. And fundamentally, this entire process took about 3 to 6 months to ship and build and get into production. And so, as mentioned before, this is not a simple ordeal. And this was something as simple, or what we now consider simple, as text extraction, right? It took 3 to 6 months to iteratively get to that desired accuracy, precision, and recall that they were shooting for. Now, let's take a look at what data science looks like today with the advent of LLMs. So, foundation models and LLMs are really built on a different starting point. Number one, they're trained on a broad range of data, which makes them incredibly versatile. They're obviously built on transformer architectures, but as mentioned, the biggest takeaway here is how adaptable they are. You don't have to worry about making the trade-offs you did last time. You don't have to worry about making the time and energy and cost investments that you had to last time. And they can do a lot of good, they can do a lot of things at really high levels of accuracy just straight out of the box, which just fundamentally makes them easily adaptable. So when we think about that same problem of text extraction, um, as I mentioned before, if we were to approach this with an LLM-based approach, you'd ideally start with a good LLM, right? Let's call it GPT-4o for example's sake. You craft an initial prompt, maybe hand label a small data set to be held out that can be used for evals. And again, you don't have to do 10,000 examples. You can do, 50, 100, 200 examples, not taking months of effort from a, human team. Maybe one individual person can knock this out in an hour or less and iteratively, get to a prompt that's representative of the problem that you want to do. And at the end of the day, you can get to that same 90% precision and recall in just a matter of a few days. And when you contrast this to something that took 3 to 6 months, it's a night and day difference. And so LLM-based approaches in the world of data science really unlock a new set of capabilities and save organizations and individuals a significant amount of time. And so when we revisit the process of training a model, what we're really doing in the LLM age is cutting out a lot of these steps, right? You don't need to pre-process. You don't necessarily need to train or tune or analyze the models or deploy it. What you have is a small, short, and speedy feedback loop that allows you to get to that level of accuracy in a very, and again, when you think about getting to really high levels of accuracy, in LLMs, it's kind of a different approach, right? Depending on the size of the model you're thinking about, whether it's a large model or a small model, there's some degree of prompt engineering, there's some degree of few shot prompting, there's some degree of RAG enabled few shot prompting, and then eventually you can get to fine tuning to get to, ideally as close to 100% accuracy as possible. So takeaways here are threefold, right? Look, whether you're doing a traditional ML-based approach to your data problem or an LLM-based, fundamentally, don't ever forget why you're solving the problem and what you're hoping to get, right? The approach is just a tool, but the problem and the method of problem solving doesn't change. Whatever results you get as an output, it's still going to be a continual experiment. You're still going to be iterating. What you're iterating on and how you're iterating is going to change, but it's still a continual experiment nonetheless. And when you're not happy, or if you're in a case where you're not happy with what you're seeing, still take a look at the data, right? Fundamentally, these are data problems. So the shape, the structure, and the nature of the data could be what's bottlenecking it. And hopefully we're building a product to make that data transformation easier, to allow you to unpack your data easier. But the takeaway here is, while the tools have changed, the techniques of experimentation and problem solving have not. And so that's a takeaway I'd love for all of you to take from this. Hopefully this gives you some guidance and some excitement on the new world of problems in data science and how we can solve them, and the new capabilities that LLMs and transformers have brought. And would love to see you guys play around with LLMs to kind of solve some of these data challenges. So with that said, I'm going to briefly transition into showcasing our product a little bit, and hopefully you guys can see my screen. And so what I want to briefly illustrate, and I'll zoom in a little bit, is an industry categorization task. So let's say you had a business and you wanted to classify it against a NAICS taxonomy. So a NAICS taxonomy is a industry classification taxonomy that exists in North America. For a given business, it describes the type of business it is. I think there's about 2,000 to 4,000 different possible labels that you can classify between. And this is not easy in before LLMs, right? Understanding the business, collecting the information that you need, and making a judgment on which category it belongs to amongst a taxonomy of thousands and thousands. That's not a straightforward task, but Refuel on the platform we're building makes it easier to solve these sorts of problems. So I'll walk you through how we would approach this sort of problem, and kind of all the wins you get from Refuel. So the process of using Refuel is a 3-step process. Upload some data, and this can be ingested in the form of a CSV, or we can read and write from your data warehouse. Set up a task, and a task is just a series of instructions that we want the model to follow, and then ultimately deploy the model, and we'll kind of walk through that in just a second. So let's take a look at this industry categorization task. So to set up this task, give it a name, pick a starter model. So you have the OpenAI models, you have the Refuel models, which I alluded to earlier, you have the Anthropic models. You can pick your favorite model, and you can easily switch between them and provide some high-level context, right? We are, analyzing data about some businesses, and we want to extract different information on these businesses such that we can classify it. And then we're going to set up some fields, right? So think of fields as just additional columns that end up in your data set. And what we want to do first and foremost was take the name of the address and search it up on Google. And let's say we have the URLs of the website as well. We want to scrape these websites as well and get as much information as possible. Once we have this web search and this website scrape, we want to classify all of this information attached to the business in accordance with a specific taxonomy. So we have about 2,500 labels, anything from soybean farming, oilseed, manufacturing. Think of any different category or industry to describe a given business. We have that included in this taxonomy, along with some information on how to classify it. And so taking this information that we just enriched our initial data set with, we want to be able to classify it within this taxonomy as well as the MCC taxonomy. So if you're familiar with credit cards or how they work, or credit card points, MCC is probably not new to you, but this is another taxonomy that businesses can be classified within. And so we have 2 different taxonomies that we want to classify within. And then we also want to return the business contact information. So given a certain business, can we get, the founder's email, phone number, physical address? Let's return all of this information in a JSON capacity. So once we have set up this task and we run it, you'll see data labels start to spit out. So let's take a business, for example. So let's take Rock's Mansion Rentals. So for Rock's Mansion Rentals, we did the scrape, we did the search, and ultimately we got a NAICS category that describes the business. We got an MCC category, and then in this case we weren't able to find the email and phone number, but we did get the physical address. So whatever is available from our searching, we're able to get that information, and not only get the information, but also get confidence scores. And why confidence scores are powerful is because, we talked about how difficult evals are in the world of data science, or at least traditional ML and data science. Now with confidence scores, you don't have to spend time verifying the quality of each and every single label. You can just take a look at the labels with the lowest accuracy and validate whether or not they're accurate. And so it's a huge win in terms of time savings. And what we've done is take it a level further and say, hey, for a given label, tell us why you produce this label. So we'll have it explained. And while that's, spitting it out, you can also provide it human feedback, with thumbs up. And if it's thumbs up, we'll take that into consideration. If it's not, you can hit edit and just give us the right, answer. And, we'll take care of everything in the back end. And so again, you're able to get to really high levels of accuracy iteratively, but in a seamless, streamlined UI. Once the data is in the shape, format, and accuracy you want, you can do two things. You can either just fine tune it, you can export it, or you can deploy it as an app. And when we do that, what you get fundamentally is an endpoint. And so you get an endpoint where you can continue to throw, more data at it. You can have it run in real time. You can scale up, scale down. But, we've taken that data and we've productionized it so you can use it in whatever capacity you want. And so hopefully what I've shown you in these past few minutes is just an end-to-end workflow of how you can take, raw data and get it in the shape and format and supplement it with, net new information that could be helpful for the type of problem you're trying to solve. And so we're trying to make this as easy as possible. We're trying to deliver ML capabilities to non-ML native teams, businesses, organizations, and people. And we're excited with all the potential that LLMs have brought and will continue to bring. And so with that, I will pause right there. I'm happy to answer any questions from the audience, but hopefully part of this was helpful for the audience.
Great, thank you so much, Kamesh. That was really interesting, and thank you for showing a demo of Refuel as well. Yeah, if anyone has any questions, feel free to pop them in the chat now. Yes, and also just so that everyone is aware, this is recorded and it will be edited and uploaded on our YouTube by tomorrow, so you guys will have access to all of that very soon. As for slides, I don't know, Kamesh, if potentially you can share it, share the slides, that would be great, and we can send that around to people as well.
Sure.
I can see some people are typing, so hopefully we'll have a couple questions soon. There we go.
Yeah. So all of our data, so we don't use any data to train any other customers. All your data is your data. It's stored in S3, and so we have the background. Can you give an example of a business, Azam? I'm not sure if you mean the type of customers that we work with, or a business in the industry classification example. If you can clarify, I'm happy to answer that. RAG, how is RAG implemented? It really depends. So we have a variety of different enrichments, and one of the things I didn't showcase was we have the ability to connect to custom APIs. So beyond web searches, beyond website scrapes, if you have different sources you want to pull and enrich from, that's a capability that we can, add in as well. Adam, can you explain how training is? So, if you saw the example here, to get to high degrees of accuracy, it's more so a process of prompt engineering as well as model fine tuning, as opposed to traditional ML training and tuning. So that's kind of the differences in this approach versus a traditional ML and data science approach.
Great. Yeah, I see some more people typing, so hopefully there are some other questions. Yeah, there we go.
So we have agents for web searching and web scraping, but I would think of this what the definition of an agent is really evolving day by day. I'm curious, Austin, what you define as an agent. The best way I've described this is an easy way to stitch together these pipelines, these data transformation pipelines. Maybe call it an agent. Different parts are different or automated in different capacities, but I guess you can say everything is moving towards being more and more agentic.
Nice. Yeah, if anyone has any questions, like I said, pop them in the chat. But totally fine if not. Kamesh did a really good job of explaining it and going through.
Something we scraped earlier. So a business. So I think the business that we scraped prior was a mansion rentals business, and so we were trying to figure out what sort of industry does that fall under, and I think it was property management or rentals or something like that. And so give the type of business, set up the task how you want to classify it, and you saw the workflow of how that looks.
Great. I see some people are typing. Oh, yes.
Yeah. Can I drop my email in the chat?
For sure. Yeah, go for it.
Okay, you can shoot me an email at, here you go.
Great, thank you. Yeah, so if anyone has any other questions, do just email Kamesh. He's very kindly dropped that in the chat. But if there aren't any other questions, like I said, this will be recorded and uploaded. Kamesh, thank you very much for coming and giving that session. It was great. Oh, yes, and links to the slides. Do you potentially have that on you now? If not, we can circulate that a little bit later.
Yeah, let me circulate that a little bit later.
So fine, don't worry.
Awesome.
Ridwan will get that to you in a little bit. But yeah, great. Thank you guys for coming. Thank you, Kamesh, for your workshop. It was great. And I look forward to seeing you guys at the next one. Have a great day, everyone.
Thanks, everyone.
Bye. Bye-bye.